for me. Hopefully, didn't scare you away the first time. Well, this is how to sort anything. I don't have to go through all the introduction. You know about me already. Too much about me, probably. But I would love to hear from you folks on all sorts of social networks, LinkedIn, YouTube, Twitter, Threads, wherever you want to get in touch with me. I'd like to hear from you. And don't forget my email list, both my Dev Developers list, all about Python, every Monday, and then weekly, where I have new puzzles based on current events using pandas every Wednesday. All right, so let's start off with one of the stage, which is sorting is important. Why? Why do we want to sort? Well, first of all, aesthetic. We might want to display our data nicely. We might want to make our messy data or less messy. We might want to find the largest or smallest value in a collection. We might want to, let's say, do sales records, find out which products sold best or worse. We might have a whole bunch of proposals. We want to know which one is going to cost us the most or the least. And then we have our real-world day-to-day situations of get the closest gas station from where I currently am, right? So you don't know the car. Find, it might be a charging station, right? Find similar films to the ones that you just watched, right? You see it all the time on Netflix and other things. Find similar products to the ones you're looking at. Amazon does that to us all the time. Right? You're looking at a product like, oh, well, there are also these things that are similar. So Python actually makes sorting really, really easy. If you have a list, so here I have minus equals 10, 5, minus 3, 7, minus 2, 4, and I can take before, take minus equals this. Right? And by the way, notice this syntax here. This is new-ish syntax in Python, where if you have an expression and then the equal sign inside the curly braces, it will print the expression and the expression's value. So I'll get minus equals and then whatever the value of my list is. So we're going to see what my list was before the sorting. We're going to see what the value of my list is after the sorting. And ta-da, sure enough, I sorted it in increasing order, what we call ascending order, from small to large. And that's great. So there are, however, two problems with list.sort, this sorting method. It is a list method, so it only works on lists. It sorts from small to large, as I said, by default. But here's the most important thing. It changes the list object itself. It does not give us back a new list. It does not give us back a copy. Rather, it changes the list. And so if I say here, my list equals, same thing as before, 10, 5, minus 3, 7, minus 2, 4. And then I say also my list equals my list. So we will see that if I sort my list, also my list changes. Right? Because my list and also my list are two variables referring to the same list. And when I call my list.sort, I'm changing the list, which affects anything that refers to that list, including both variables, my list and also my list. Right? So after also my list is going to be minus 3, minus 2, 4, 5, 7, and 10. Now, the other thing to watch out for is, and I see people make this mistake all the time. They say my list equals something, and then look here, they say my list equals my list.sort because they want to sort my list and then get back the sorted version. Well, before it's this, and after it is this. None. This is a very common mistake that I see people make. And what's going on here? Well, it turns out, let me just go back here. This is because it's a pretty standard thing in Python that if you have a method that modifies the object, that method returns none. Right? People from other languages often expect that we will get the object back even if the object was mutated, and that's not the case. If the object was modified or mutated, we get back none traditionally. Well, it turns out that there's a much better solution here. Sorted. Sorted is not a method. It's a function. It's a built-in function. And it works with all variables. It does not just work with lists. And it always returns a list. So you can sort a tuple, you can sort a dictionary, you can sort all sorts of things, but every sort you're getting a list back. Sorted again by default from lowest to highest. And because it does not modify the source data at all, it's safer. You don't have to worry about accidentally messing up someone else's data. And how does it work? Well, actually, it's really similar to what we did. If I say, here's my list, and then I print sorted my list, and then I say, after sorting it, my list is what? See what I'm doing here? I'm calling sorting on my list. I'm going to print the results. But my list is not actually changed. My list remains exactly as it was, because as I said, sorted does not change the original data on which it ran. Okay? So, how are things being sorted? Well, it's very nice when you can sort things this way. And the sort algorithm, people always ask me which algorithm to be used. And they're like, oh, we did quick sort or keep sort. No. We're using Tim sort. Tim sort invented by Tim Peters. That's why I got it called him. If I create that using called Reuven sort, then no one will be able to spell it, so we're really big trouble. So Tim sort, basically, its big genius idea is that even real world data that supposedly is kind of random actually contains natural runs. It contains natural groups of pre-sorted data just because of the way the world works. So Tim sort does a combination of Tim sort does a combination of merge sort and insertion sort. And so basically it does an insertion sort of little pieces and then it merges them together. And so it actually works really well. In fact, Tim sort is used in a whole lot of programming languages other than Python. It's not just a Python thing. So, okay, that's nice, but how does it compare to it, right? It's actually compared to using the less than operator. Because given items A and B, we'll need to know whether A is less than B, or A is greater than B, or A is equal to B, right? It's got to be one of these three. It can't be more than one. And so when it's versioning and sorting, Tim sort is going to use this comparison. It's going to start with less than. That's like the easiest one. But if it needs to use the other, we'll talk about that in a little bit. So if we have a sequence of numbers, we can just use less than, greater than, equal for the comparison, right? It's not that hard. But what if we're sorting something a little more sophisticated? What if, for example, I have a string and I want to split on that string? I'm going to get back a list of strings. And if I sort the list of strings, how's it going to be sorted? That's right, it's going to be sorted. Well, we call it alphabetically because you can see it's sorted alphabetically. The younger people here might not remember, but once upon a time, we had these things called books. And once upon a time, one of those books was this thing called a dictionary that had all the words you could possibly use in alphabetical order. If you want to look things up, you could use alphabetical order to find things in there. I'm being sarcastic, I know. Even the older people here probably don't remember what books and dictionaries were. I'm old. In any event, what we're doing here is we're sorting in dictionary order, meaning we look at the first letter. If the first two different words, we're going to compare them. If the first letters are different, then we just first learn those letters. If they're the same, we go to the second letters of those words. If those are the same, we go to the third letters of those words. We eventually get to a tiebreaker. So you can see how we can sort these words. That'd be great. And so a one character string can be compared with less than. And a multi-character string, this is just describing what I just told you. We check 0, index 0, then we check index 1, that, right? If it's 0, we can go either way. And it's not we do this one, we do this 2, we do this 3. And basically, if they are equal, then we return word 1. But if one is a substring of the other, then we return a shorter one. So if I have ABC and ABCD, ABC, the shorter one, will come first. But if I have ABB and ABC, then ABB will come first because its character at index 2, B, comes before the character index 2, the other one, which is C. Now, this sounds familiar, as I said, like this is how we look at words in the dictionary, but it gets better than that. Because Python actually does this on all sequences. If you have a list of strings, right, if you have a list of lists, it looks at index 0, index 1, index 2. It looks at tuples, index 0, index 1, index 2. The list of tuples is looked at less than exactly the same way as this. So if I want to compare lists, right, I can say, is 10, 20, 30 greater than or less than 10, 20, 15? And the answer is, it is actually 10, 20, 30 is greater than 10, 20, 15 because of the value of index 2. What happens though? What happens if I have a list containing multiple types? So I have 20, BA, 10, and 30. How is this going to be sorted? And the answer is, it won't be. I will get an error message. The error message says, less than is not supported 3 instances of stirring in, meaning, hey dummy, I don't know how to compare whether a string and an integer, which one is greater than, which one is less than the other. It doesn't make sense to me. Now you should know, earlier versions of Python actually did allow us to do this in Python 2, and it was super unhelpful. Like, no one actually wanted to perform that sort, and it allowed us to, and it was just okay. So in Python 3, they got rid of it. Meaning we now get error messages where we did not perform, that's a good thing, because these error messages stop us from doing things that we probably don't want to do anyway. And I should add also that lists traditionally in Python, even though you can put any types of data you want in them, any mixture at all, realistically or traditionally in Python, a list contains all elements of one type. So mixing up types this way, technically there's no problem with it. Python police will not come to the rescue. However, it's kind of doubtful. Okay, what if I want to reverse the direction? Right? We said already that sorted and list dot sort are always returning in ascending order from smallest to biggest. But I can say sorted in my list, reverse equals true. I pass the reverse equals true keyword argument, and now I get back 30, 20, 10. Okay. So really, we do an ascending sort, we do a descending sort. As long as I've listed all the same types, and those types know what to do, we are doing great. Okay, but now, what if we want to do something a little more sophisticated? What if we want to sort a list of words, but not by the words, but by their lengths? In other words, we no longer want Tim sort to compare word 1 and word 2 with less. Rather, we want Tim sort to compare the length of word 1 and the length of word 2. Now, don't be fooled. Don't think that what we want to get back is a list. We don't want the list of word lengths. We want still a list of words. We want the words to be sorted by length. So how can we do that? And the answer is we can use the key parameter, keyword argument. If we have a function f, we want to compare f of a and f of b, right? Where a and b are elements of our list, of our interval. So what I do is I can call sorted with key equals f. What happens then is each element of the interval, each element of the thing we're sorting, is run through f. Sorted then has the result for that function on each element, and then it sorts them by the result. So here, for example, I want to sort the words by length. So I can say key equals length. Here's how it will look. Words equals, this is a bunch of words, that's split. And then I say sorted of words, key equals length. And now I'm going to get them in ascending order by length, not alphabetically. So if A is of this bunch of words, because that's one character, two characters, 4, and then 5. This seems really powerful. And guess what? It's really powerful. Because any function that takes a single argument and returns a value that can be compared with less than, it is usable in this context. And that's a lot of functions. So the function takes one argument, that's going to be one element from our list that we're sorting. And as long as it returns something that's comparable, meaning probably in most cases an integer, it could be a float, it could be a string, it could be a list, it will work. So here's some examples. If I say sorted words key equals length, sort the words by length, we just saw this. If I say sorted of numbers key equals abs is a built-in function that returns the absolute value of the number. So this will sort the numbers by absolute value. I say sorted words equals stir dot lower. I'm going to sort the words ignoring the case. Right? So basically it's going to run stir dot lower all the words, and then it will return, which from lowest to highest, from earliest to latest, ignoring the case. Notice that we pass a method like stir dot lower by passing it as a class attribute. So I'm not saying there's no way we would call dot lower on an actual string. We don't have to string it. We have to pass it as stir dot lower so it can be run, but that's totally fine. Notice also, very, very important, we are not invoking these functions and methods. There are no parentheses here that we're using after functions and method names. Rather, we are passing references to those functions and methods, left, ABS, and stir lower, and sorted internally will run each of them multiple times, once for each element. Right? So it's a common mistake to use parentheses after the key function's name. So this will give you an error. When we try to run key equals abs, we get an error saying, wait a second, you're trying to run abs on what? We don't want to run abs ourselves, we're going to let sorted run it for us. I can't stress this enough because it's a common mistake. Okay. What if I have a list of lists, or if I have a list of tuples that I want to sort them by length? Once again, I can just say equals length. Because len works on lists and len works on tuples. So just as I can say equals length to sort a list of strings, I can use equals length to sort a list of lists. What if I want to sort them by the sum of the numbers inside? Well, then I can say equals sum. And it will sum up each sublist. right? Each of the individual lists there, and it will return them sorted from lowest to highest. So what if I want to use a custom key function? What if I want to create my own function and then pass it to key? Can I do that? Yes. If I pass a function that I wrote, and that function takes one argument, which will then be an element level sorted, and the function returns a value that is sortable as complement, then we're fine. Note that the value returned does not need to be the same type as the input. So when I sorted, think about this, when I sorted my strings by length, I was passing key length. Len takes a string as an input, but it returns an integer. So they don't have to be the same type. It's great. So for example, let's say I want to sort these integers by the number of digits. Right? Not by their value, but by the number of digits. So something with one digit should go first, and something with 4 digits should come last. So I'm going to say def by digit count n. I'm going to return the len of skill n. So what's happening here? My function gets an integer, turns it into a string, counts the number of characters there. And so now I just have to say print sorted of numbers, and key equals by digit count. Am I turning numbers into a list of strings? No. Am I changing numbers at all? No. But I am getting back the elements of numbers, the integers there, sorted according to the number of digits. And here we go again. 1, 30, 40, 500, 100, 2,000, 1,000. And you might be saying, wait a second, what value is going on here? 30 comes before 40, but 500 comes before 100, 2,000 comes before 1,000? Yes, that's because tip sort is what we call stable sort, which means that if two elements, have the same results from our sort function, from our key function, they will remain in the original order. So in the original data, 30 comes before 40, so it remains 30 before 40. But the original data, 500 comes before 100, so it remains that way. 2,000 comes before 1,000, so it remains that way. I can also do this. Here I have a list of lists, and I want to sort according to the mean of each sublist. That's fine. Say def by mean of one list. And by the way, it's only using the word by at the front of the function name. This is a thing that I do. I think it makes it more readable. You can adopt that if you want, or you can hate it. But if you hate it, don't. In any event, so I'm going to find my function by mean. It's going to take a list, it's going to take one of these sublists, and it's going to sum it and divide it by the length. So now we will get back our lists, our sublists, sorted by their means. Right? I can do even better, or more interestingly, perhaps I can sort by vowels per word. What do I mean by that? Well, here I have a bunch of words. This here is a fascinating and scintillating text. So I can now say def by vowel count. And by the way, here I can say print. I can put a print in there in my key function, and then I get a little update with what's going on. So long as I don't have a lot of elements in the list, I'm okay. And then we're going to do total equals 0. Then we go through the word and check to see how many vowels it has. And the word turns out total. In other words, I would get back the number of vowels in a word, and then use that for sorting. So if I say print sorted words, key equals by vowel count. What is it going to look like? Well, first of all, it's going to report to me on what it's doing. Checking this, checking here, checking this, checking A, blah, blah, blah. And then it sorts it by the number of vowels from lowest to highest. Let's get even fancier. What if I want to sort file names by the file names? In other words, I have a list of file names. And I'm going to get that here. Well, here we go. I def by file name. So I get a file name, and I use os.stat on the file and get its size. So this will return an integer given a file name. Now I say blah 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 start out txt. So I'm going to find all txt files in the current directory, and then I'm going to run by file length line. So I'm going to get back a list of file names sorted by the length of the corresponding files. And if I do that, I get them back here. And this happens to be true. What if I want to combine what I just did, sorting the file names by the file count? So now we're going to get a file name. We have to open the file, go through, get its file count. That's not so hard. I say def by value, and I throw a file name. Total equals 0. I say for one line, we go through each line. For one character, we go through each character. If the character is a vowel, then we add 1 to the total. And so now I can say print sort of blah 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 to start a txt. So find all the text files in the directory and sort them by the vowel count of the file name. We're going to get back this file names. Here's another one. we'll do this example. Right? What if I have a list of dictionaries, where each dictionary represents a person record, with their name, first name, last name, and their age. Can I sort this? Let's try it. When you say sorted on people, it's a list after all. No. It's not working. And that's because you cannot use less than across dictionaries. Less than words greater than integers, floats, strings, lists, and tuples, but not dates. So what do I do now? Right? How can we get around this error message? And the answer is a key function. Because the key function can get any input, the key function can return any output, so long as the output is sortable, we're fine. So I can, for example, sort people by age, deaf by age, D, that's going to be one of those little dictionaries. Return the age. So this just assumes that the dictionary returns the age from there. So I can say, print sorted people, key equals by age. And now I will get back that list of dictionaries sorted by age from smallest to largest. What if I want to sort my last name and then my first name? Can I do that? The answer is yes. If I have the key function return a tuple, because we know already that PyHo knows how to compare and sort tuples. So if I say here by last and first, D, and I return a tuple, last name and then first name, now when I sort people by last and first name, it will work beautifully. Okay? So you see that these sort functions, these key functions, can be really sophisticated, really useful. Now, why write a key function? Maybe what I'm trying to do is already built into Python, it just require a whole new function. I could use lambda, and lambda confuses a lot of people, but lambda is just a construct that returns a new function object. It's an anonymous function. So it doesn't have a name, but it's a function object. And if we use a lambda function, it's just a single expression. So instead of saying key equals by last first, like I did before, I can just say key equals lambda d. Lambda d is going to create a function object that takes one argument, d, our dictionary. And I return a tuple last first. And I'll get exactly the same result as before. But wait, it gets better. Because I would say, let's use operator item getter. An operator item getter is a function that returns a function. It's designed for exactly this sort of use case. So if I want to, I can sort people by age by just saying sorted people key equals operator item getter of age. And operator item getter is basically a function version of square brackets. It says let's go into the current object and retrieve its age from there. What if I want to get both last name and first name? I can still use item getter because item getter contains more than one argument and just pop them together. Two arguments, last and first, we'll get back to tuple. That works just fine. What if I don't want to use a list of dictionaries? What if instead I'm going to use a class? So here I'm a class person. Def under A. And so to create my class, I'm going to create an instance of a class first, last, and age. So now I'm just in an object version of what I did before with my dictionary. Can I sort this? What happens if I create my 4-person object and then I try running sorting on people? And the answer is, it goes up again. Why? It's a very similar error message. Less than is not supported to be instances of person to person. So what do I do now? Well, obviously we're going to implement less than. How do we do that? We implement the Duggar LT method. Duggar LT less than. Basically, our object is on the left. That's going to be self. The other object is going to be the right. That's going to be other. And we just say, is our age less than the other age? If true, great. If not, sorry. And so, you know what I can do? I can even create equal. I do that with Duggar EQ. So Duggar EQ is going to return whether self.age is the same as other.age. So you see what I did? I have less than, I have EQ. And now I can sort my last and first names. Right? I can do all things I can do LT and do EQ. All of these are totally fine. So you guys can close the window for hearing a birthday party for my neighbors. But they're hearing a Python lecture, so they win. Anyway, so if I want to sort by both last and first names, I can do this here. I can just do exactly the same comparisons as before, except instead of comparing age, I'm going to compare last and first with a list. But what about other comparisons? What if I want to check if a person equal 1 is greater than or equal to equal 0? And this is where it falls apart. Because I define less than, and I define equal, but I did not greater than or greater than equal. So it's going to be analysis. But there is a solution, that is total ordering. If I use the total ordering decorator from functional, this uses, you have to at least define LT and EQ. But if you define those two, then it defines all of the remaining comparisons. So it'll be greater than equal, not equal, so on and so forth. And now it works just fine. So total ordering is a great thing to add. Now I should add, as in Python 3.7, we can use what's known as data classes. And our data class is not taking off nearly as much as anyone thought it would be, but there's still kind of interesting people on the other here and there still use them. And the idea is basically you have a class that, like doesn't have a lot of methods. It's just easier to define your class with some almost like Java style declarations. These are the attributes that I want. So I can create a person class using data classes, from data classes or data class. And I'm going to say data class order equals true. Notice that that's order equals true. And I just say count. Goes first line, today, store string it. And so here is where I set up the data class. Here is where I have the attributes named. And now I can just create my instance as a person. And everything else that I did before also works. I can sort them. It works just fine. So if you have a data-only class, this is actually not a bad way to go at all. But wait a second. If I go back here, I said that things are sorted, and they are. I didn't tell them how to sort. I didn't tell them. So how is it sorted? And the answer is in the order that attributes were declared. So if you want to modify the sort order, you need to change the declaration to the attributes. So if I want to sort by last and then first with an age, I can put them in that order, last and first and age. And now my sorting happens by last name, then first name, and then age. Alright, so in summary, Python's sorting function really lets you sort anything. And the key, no pun intended, to this working is the key function, which means any function method that takes a single input and returns a sorted level. You write your own function, you can use a lambda, you can use the operator writing together with one or more arguments. And classes are sortable if they define some methods, and I suggest use total ordering. And data classes can make it even easier. Alright, folks. I would love to answer your questions if you have any, although we can have some audio problems. We'll hear from you. Either now or in general. After the talk as well, we'll be totally fine. Any questions, folks?
We didn't hear a clap. Hello?
Thank you, everyone.
Hello?
Thank you so much, and thank you for your generosity. I hope to see you in person one of these days. Hopefully in Ghana, if not, there's another conference.
Yes, definitely. He will come to Ghana next year, 2025.
Absolutely. All right, folks.
Any questions?
Bye for now.
Any questions, please? Yeah, we have one question for you.
Excellent, excellent.
No, just.
Hi, Lerner. Thank you for the presentation. I have a question, and it's with my experience using Python 3.12 all the way to 13. I did realize that with Python 3.12 and 13, most of the packages out there in libraries are not like compatible with it, and they often really break. I think because of the new underlying architecture. So I'm not sure like if you can just explain how we could actually go about that roadblock.
So that's not supposed to happen. In theory, every time there's a new Python release, it should not break existing code. It should just work. If you're seeing things that are breaking, that's probably either a bug in Python or a bug in the library that you're using, but they're not doing it the right way. But I believe you. Like, I believe you that you have things break. It's not supposed to happen. At least the sorting things should still work. But I don't know. That's a great question. question. I wish I had better information for you, I'm sorry.
All right, thank you. Do we still have another question? Yeah, we have another question for you.
Fantastic.
Yeah, hello, Lerner. You mentioned that there's something can happen on a sample of data types, but I didn't hear you. Maybe if I did, I didn't hear you talk about sets. Does it work really good with the set data type?
Okay, so I love sets. I really, really do. And I'm glad we have another set fan in the audience. So here's the thing, sets, you can sort them. They're totally 100% sortable because it's just iterating over their elements that they can use. You'll get back to this. You can think of a set as just the keys of a dictionary. Like I sometimes call them immoral dictionaries because they don't have any values. Anyway, basically, you can totally run sorted on a set, and you can have the elements of the set in sorted order. There's nothing wrong with that. Yeah, totally should work. I think, I don't think, I can't imagine not working.
All right, thank you. Any more questions? Last one, please. We have an extra one.
Hi, Reuven, and thank you for your presentation. I would like to know, in some parts, you use the built-in function called .sorted, and I want to find out the time complexity if you are looking at either best case, worst case, or average case.
Oh my God, I do not remember whatsoever. I might be a guess. I'm sure you can look up and find it. It's not that bad. Like, it's actually, like, there's a reason why a whole lot of other languages have adopted to sort for their larger objects, because compared with the others, it's overall pretty good. I want to guess and log in, but I'm not really totally sure. I mean, I'm sorry. You will fail your job interview question if you rely only on me. You don't have to something like that. But I think I can help there.
Okay, thank you.
All right, thank you. All right, so that's it, Lerner. We thank you for your time, and hopefully we should have you in person in Ghana sometime.
You bet. I'm looking forward to it.
All right, sure.
All right, folks. Thanks so much. Enjoy.
Yeah, bye-bye.
Bye-bye.